All right, guys, I'm ready to nerd out. So we're going to start with some trig identities. So this is a point where you like pause and make sure to get all of these written down, a picture taken of the screen. I don't know what you do, but you need to know these. If you write them down, you are more likely to remember them. The more you remember, the easier this is to do. Okay. So we've talked about reciprocal functions before. So they're just equal to one another. Remember, cosecant is the reciprocal function of sine, so it means it's equal to the reciprocal of. Remember when we did the unit circle, assuming that you completed the third unit last semester? Tangent was equal to sine over cosine, and cotangent was equal to cosine over sine. We also have some Pythagorean identities, and most classes, when they're like, hey, this is what you need to memorize, they just say, hey, memorize these three, which is absolutely correct. And if you only memorize one of the three, that one's the most important there. Sine squared theta plus cosine squared theta. Make sure to memorize that one. But I wrote all of these down so that you realized that they were the same. So if I have sine squared theta plus cosine squared theta equals 1, remember that that actually makes 3 true statements. Because if I were to move sine over to the other side, I'm left with cosine squared theta equals 1 minus sine squared theta. If I chose to move cosine to the other side, I get 1 minus cosine squared theta. That's where the other 2 rows come from. So you'll notice that all 3 of those are sine, cosine, and 1. Same with the tangents and the cotangents. To make this video shorter so that you are not listening to me ramble all day, I'm going to skip the reasoning why. However, there are lots of videos as to why all of those work. It basically comes down to sine is y, cosine is x. So x squared plus y squared equals 1 squared, which is 1. So that's why sine squared plus cosine squared equals 1. And then the others aren't too bad, but you can Google them if you're super curious. So what is verifying an identity? It's essentially a proof, but you don't have to be scared of it like maybe you think of geometry proofs. They're not really that. They're just saying that one side is equal to another, which is our ultimate goal. But right now, you'll notice there is no side, meaning one side and another side, meaning there's no equal sign. So this example is asking to use the quotient identity to simplify and rewrite. So cosine beta, just another Greek letter, is equal to sine beta over cosine beta. Because, scroll up a little bit, tangent theta equals sine theta over cosine theta. Okay, remembering my fraction rules, if I put that over 1, the cosines cancel. I'm left with sine beta over 1. Which we all know the 1 is not necessary. So we just have sine beta. Okay. Other thing, so this one works pretty much the same way, but it's 3 things being multiplied. We got to practice some of our algebra skills. All right, so for fractions, we're going to think cosecant theta divided by sine theta. So if I were to change cosecant theta times sine's reciprocal would be cosecant theta, which would then be cosecant squared theta. If that lost you, you could also think about it as cosecant theta divided times 1 over sine theta, because remember, fraction rule says that if I divide by something, it's the same as multiplying by its reciprocal. And then this one is equal to cosecant theta. if that helps you a little bit. That's why I said it was so important to get this square down. And again, the more you memorize, you're not looking at that sheet for, you know, hours. That's exaggerating a little bit, but the idea is the same. What happens if I have one denominator, two different top pieces? So 2 terms on the top. I can actually split them so that it looks like this. Well, this part's easy. That's 1. Okay. This becomes sine x divided by cosecant x, which is the same as sine x divided by 1 over sine x, which then becomes sine x times sine x, which is then, so that minus 1 should have been down here. Sine squared x minus 1, that's a Pythagorean theorem, so all of that work is the same thing as cosine squared x. Okay. Factoring. We got to remember our factoring rules. So in this case, think of it like 2x squared minus 3x plus 1. What would you do? Well, that would become 2x and then x. But in place of x, we're just going to put sine. X. Same goes here. This is a difference of squares. So 4 plus secant x times 4 minus secant x. This is all kind of like the basics to get us to the next step. We could also have, I call it unfactoring, or no, I don't. I call it undistributing, which is actually called factoring out the greatest common factor. But what they both have in common, P.S., undistribute is not a word, but so cosecant alpha, if I factor that out to the front, I have 1 remaining here and cosine squared alpha here. And then if I wanted to, that would also factor as 1 minus cosine x and 1 plus cosine x. It would also be sine squared x, and so then I would have some things cancel, but that's looking ahead. This one's a tricky one because there's 2 different ones. However, if I go up here and look at my box again, cotangent squared theta is equal to cosecant squared theta. Whoops, let's look at the other one, sorry. Cosecant squared theta is equal to 1 plus cotangent squared theta. So I could actually replace cosecant squared, this is beta, with cotangent squared beta plus 1. Then I could do the cotangent beta minus 3. Then I combine those. And now it looks exactly like example 1. Not exactly, but same idea, using the same knowledge. Has to be a -2 and a +1 in order to multiply to get -2 and add to get -1. The last part I want to cover is even and odds. If you have cosine -x, that's the same thing as cosine x. They are equal to each other. And I was saying in class, whatever cosine is, so is secant, same thing here. For sine x, it's actually equal, or for sine of -x, it's actually equal to negative sine x. And again, cosecant would be the same. And tangent is negative tangent x, negative cotangent x. So all that means is if sine theta was 1/2, then sine negative theta is equal to negative sine theta, which means it is equal to negative 1/2. Okay. We will stop there for the video, but there is a lot of practicing to do for being prepared for this. Like, I could make a 30-minute video where you just keep watching everything that I do, and it still won't make sense until you physically try it yourself. So that's why we are going to use a lot of time to practice in class instead.